Welcome back to another installment of the miniquad build video. And last time we left the miniquad in this state here, it's all ready to go. So we're going to put it to one side because now we're going to do the flight control of the Naze 32 board. Now, as I said, you can buy these either pre-soldered or you can solder them yourself, and I like to solder them myself because it gives me a few options. I might not want all the pins soldered because some of them are not really used for anything that I might want, and it means I can choose between having straight pins or angled pins as and when I want to. Now, this box it comes in, don't throw this away. As I said before, with the piece of plastic acting as an insulator on the miniquad frame, I like to repurpose stuff. I don't like to throw stuff out. So we're going to use bits of this box later in the build. So don't throw it away. This foam rubbery stuff here, very, very useful. Now, I'm going to solder the pins on mine. Mine comes with these ones come with a whole selection. There's a cable and a set of right angle connectors here, somewhere in this, here we go, for the ESCs to plug into. Now, one thing, at this stage you're going to have to decide whether your radio system uses CPPM or whether it uses PWM. What's the difference? Well, CPPM only needs 1 or 3 wires from the Naze board to your receiver, and PWM requires all these wires, well, not all of them, but at least 5 of them, or 6, 7 of them actually, to go to your receiver. So what normally happens is you solder a connector on the side here, which is provided in the bag. We'll show you what that looks like. This connector, and if you buy them already soldered up, this connector will be on anyway. And that's a bit of a pain because it actually pokes out the side a little bit of the miniquad, and you know, something can get broken. That's why I like to use CPPM, or PPM as it's sometimes called. Normally this will plug onto that connector there once it's soldered on, and these wires will go off to your receiver so that your receiver can talk to the Naze board, send the control signals through. But if you go the CPPM way, then you can leave this off and you can get an old servo extension, if you've got old servo lead or something, and just solder the 3 wires from that. What do we got here? Even something like this is just a wire lead dummy. If you have one of these laying around, you can cut this off and solder the wires onto there, which is what I will be doing on this one because I run CPPM in my receivers, and it's so much easier and simpler. But I'm going to go ahead and solder this one up, and so I'll show you what it looks like when I'm done. So as you can see, I've soldered these edge connectors on here. I use the right angle ones. It's a pretty simple task if you've got a good iron and you know what you're doing. If you're at all worried, then buy the one that's already soldered, but you will have all these other connectors on the side. And there are some here that I don't use. We've got a buzzer and a battery alarm and a telemetry output to the FrSky radio system. So I like to keep it simple. I only solder on the connectors that I know I'm going to use. So these other connectors here that come in the bag, I just keep these ones here for perhaps later on if I decide to add the telemetry or something, I'll put that on then. But no, the basic board, all I do is just put this one set of angled connectors on right angle connectors, and then I put a little pigtail servo lead, you know, perhaps off an old broken servo, put that on there to plug into the receiver for CPPM if the receiver supports CPPM. As I said, if you don't have a receiver that'll do CPPM, then you're going to have to put this on here, and then you'll have to use that big plug with all the wires to connect it up to your receiver. So here's an old pigtail I've scrounged off a dead servo, an old 10-gram dead servo, and what I'm going to do is I'm going to tin these pads, solder this wire onto here so that I have the lead that it'll go straight off and plug into my receiver. And if you're using a CPPM receiver, this is the way that the wires go. The black or the brown wire goes to there, the red wire goes to this with a little dot beside it, and the signal wire, which is usually white or yellow, goes to 1 because everything goes through the first channel. And there's our pig lead, and that will just, a pigtail that will just plug into our receiver's CPPM channel. Simple as that. Before we mount the Naze board on the frame, because we're going to put the receiver underneath, we need to put some Velcro on the receiver and some Velcro on the frame. You could, I don't know, you could probably use other methods for mounting it, but I find Velcro to be really versatile and nice and cheap, and it really works well. So I've cut a piece of Velcro. Now remember, just in case you're not aware of it, when you're putting stuff on with Velcro, a good rule of thumb is there's 2 parts to Velcro. There's one that has hooks like this, it can feel like quite rough, and there's another part that has what we call fluff, which is soft and fluffy. Always put the hooks on the part you're not going to be dropping on the ground. If you put the hooks on the thing like your battery or your receiver and you drop it on the ground, then it will pick up all the little bits of dirt off the ground and you'll never get them out of there. So you want to put the fluffy on the things you're going to drop so that when you drop them, the dirt will just brush off. It's simple, and if you keep that consistently, then you won't end up with the situation I've seen so many people find themselves in, where they go to put a battery on something or put something on and they find they've got fluffy on both sides or hooks on both sides because they haven't really developed a strategy for making sure everything's consistent. So here we go. I'm just going to stick my Velcro down here under the flight controller, try and get it in the middle, and really this Hobby King blue Velcro is just the bee's knees. It's the shizzle. It's really good. I don't use any other Velcro. It's so cheap and it's so damn sticky for Velcro. So I'll put that on there. I'll now put the opposite on my receiver and we can push the receiver into place. So here we go, installing the receiver. Done. How quick was that? It's so simple. But before we go putting our naze board on the top here, must remember to bind the receiver, because otherwise once you've got that board on there you can't get at the little bind button on these receivers. So we need to bind it and we need to set the fail-safe. Very important, you must have fail-safe on these mini quads. If you just leave it without setting the fail-safe, then most receivers out of the box, if they lose the transmitter signal, they'll just keep outputting the same signal they got before they lost reception. And that means if you're flying along or climbing out in your mini quad and you run out of range for whatever reason, it'll just keep climbing. And if you're in self-leveling mode, it'll just keep climbing till it disappears or the battery goes flat, because it will be nice and stable and just disappear. So we've got to make sure on our mini quads or any quads that you do, or any actual model at all, that you set the fail-safe. So there's been a lot of debate about, what should you set it to? Should you set it so it's just a little bit of throttle so it descends slowly and bounces off the ground? Or what do you do? Well, my philosophy in setting fail-safes is you set it to cut the motors. It's going to fall from the sky, but these things, they won't break. They're tough as old boots. If you set it to descend slowly by bringing the throttle back to say 30%, then the results, it may come down gently, but once it comes down, if you're not there to quickly unplug the battery, it's going to sit there trying to turn these motors, which may be, caught in grass or whatever. It's going to burn a whole lot of stuff out. It's not going to be good. So fail-safe should be cut the motors. Now the naze itself has a fail-safe facility, but we're not going to use it on this because really it only works when you lose the pulses from your receiver. So it's not really necessary to use it on this. Most modern RC gear has built-in fail-safe. Use it or lose it, as they say. Now with the D4R2, there is a little jumper you have to insert to make sure it works in CPPM mode. If you're not using one of these Fresco receivers, then you can ignore this bit because it's completely irrelevant to you. But there's a little jumper you put between these signals, the signal pins on channels 3 and 4 like that. So that's at this end here where the little jumper is there. Put that jumper across those pins and that will tell the receiver, hey, it's just send everything out on channel 1 as a CPPM signal. Very important that you do that. Otherwise, you'll only get channel 1 going into your naze board and nothing will work properly. So now let's bind this little baby up. Now here's something I find really useful when I'm binding receivers, setting models up. And it's just a 2-cell LiFe battery, which is 6.6 volts, and a switch and a connector. So I can plug it into my receiver, I can turn the switch off, plug it into my receiver. And then when I want to bind it, instead of trying to connect XT60s and fart around while I'm holding down the little button, all I can do is flick the switch. And that will result in the receiver coming on. Obviously it's not bound, there's no transmitter signal, so it flashes, but it's much easier just to flick the switch while with whatever you've got nearby, you hold down the bind button. Much easier to do that than to fart around doing it another way. So spend what, $3 or $4 on one of these batteries, or you can just use an old receiver pack you might have had from your Nitro days, or even a 3-cell LiPo with a Beck on it, but that's getting all real complicated. I find this just so simple, and that's what I'll do. So let's bind this baby up, then we can stick it in the machine. Okay, so we're all set up here. I've got my Tyrannus in bind mode. You can hear it going beep, 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 beep all the time. What I do to bind this, of course, I hold down the little button on here. There's a little button that you hold down and then you turn it on, and I'll do it so you can see the LEDs, make life easier. If I can get it around the right angle so you can see the LEDs. Turn it on and you'll see the green light comes on and the red light's flashing. Now I can release that, turn this off, exit from the bind mode, turn it on again, and we get a green light. It's quite a feeble green light, but it's there. That means we're all bound up. And because I'm so close to the Tyrannus, the telemetry says it's lost, it's found, it's lost, it's found. Anyway, there we go. Simple bind process. Now, to set the fail-safe on the FreeSky gear, I'm going to make sure my throttle's down at minimum, which will be effectively cutting the motors. I'm going to make sure that it's switched to self-leveling mode, which is where I'll put the switch in. I'm just going to hold this down again, and we'll get a bit of a flash. We don't, I can't remember. I can't remember whether it's you hold it down for long or just give it a quick one. So held it on for a long time and I gave it a quick push. Now my fail-safe should be set. Piece of cake. Done. Let's mount this in the quad. So for the second time, I shall take my receiver and stick it in the right place. But before I do that, I'm going to plug this lead in. It's much easier to plug it in before you have the receiver mounted. So I'll plug it into channel 1, like so. Now I can stick my receiver under here and it won't need anything other than that Velcro to hold it in place. It's pretty sturdy. It's not going to go anywhere. Now I can just put my nose board in, just turn it around so the wire is perhaps in a convenient place. I might run the wire inside those posts, push it down onto the mounting posts like so. Ta-da, there you go, look at that, isn't that brilliant? Of course I'm going to put nuts on it, but you can see there's enough clearance there between the receiver and the board, nothing's going to happen there. And now I can get my little plastic nuts that I spoke about earlier, 3mm plastic nuts. You could use metal nuts, but plastic is so much better because it's not going to risk shorting anything out on that nose board, and we don't want to short stuff out. That will ruin our day. So here we go. And you don't even have to put all 4 on. Sometimes I only put 2 on diagonally because I'm lazy. I mean, there's no stress on this. The nose board's not going to go anywhere. So you can, if you want to, just use 2. But I'll use all of them this time. Here we go. Because I'm doing a build for you. And if it was for myself, I wouldn't bother. But this is for the viewers. So, got to do it right. There we go. Now you don't have to torque these down very much. I just torque them down by hand because plastic stretches. So once you're torquing down by hand, it's sort of, they self-lock quite a bit. And there you go. Our nose board is now installed. Isn't that simple? The receiver is now installed. That's even simpler. What we're going to do now is plug in these ESCs to the right pins on there. And that's simple still. I'm going to put a little diagram on here. I'll put some writing over the quad so you can see. I'll just pull out a bit so you can see. So you'll know what the motor numbers are. See, that's the motor numbers. And then that will allow us to connect the right lead to the right pins on the nose board for our ESCs. So we go 1, 2, 3, 4. Pretty simple. So this is ESC number 1, and it's a bit of a tight squeeze getting this wire up here actually on this one. Notice these afro things are a bit short, but you can do it. The signal lead, that's the little orange wire here, goes to the top. And this is pin 1 here. This is the one starts here. In fact, oh, can we get it in? Yes, we can. Look at that. So it's a little bit, there's no tension on it, but it's, yeah, I'll run it over the top, make it a bit, yeah, not really all that happy with that. These wires on the afros could be longer. It's a bit of a pain, but never mind. So this is number 2. And again, the orange lead goes to the top. In fact, I might just pull in a bit here so you can see more of what I'm doing. So the orange wire goes to the top, number 2. This is number 3, so this has to come here, and again orange wire for the top. Now if you have the straight pin 1, of course, you'll be plugging these in the top, but there's not a lot of space between the board and the top frame, so depending on what size standoffs you use and everything, so you have to tailor this a little bit to your own setup depending on your receiver and so forth. And this is number 4. So if you get these upside down, nothing bad will happen, but it always pays to try and get them up the right way to start with. There we go. So now we have our things wired. Now we're going to obviously, yeah, I'm still not happy with the length of these leads actually. This is the first time I've encountered this problem on these. I don't know what's going on, but that we'll just have to do. I don't think they'll get broken or pulled out, and the props aren't going to catch them, so that'll be fine. What I'm going to do is actually put a little bit of a cable tie down the bottoms here just to hold them down there later on so that they're not going to be loose and floating in the wind. So there we go. Now we've got our nose board hooked up. It's really simple, isn't it? Who would have thought you could do this so quickly? Antennas, we'll run those out later because they'll be going off through the top frame, and we're using cable ties for those. But now what we've got to do is start connecting up the nose board to a laptop. Yeah, I'm sorry, you're going to have to do a bit of programming. I know. I've done a video on this already actually, so I'll probably link that through in the description of this one, but I will repeat myself because you know, some people just say, how do I set up the nose board? Even though I've put in a link in the video description, they won't go there. So I'm going to do it again. So we'll have our aerials up there eventually. And to do the setup, you're going to need a laptop, or a desktop, doesn't really matter, and a micro USB. Now micro USB matches that connector. This is micro USB. You're also going to need some software to put on your computer. First thing we have to do is plug the micro USB lead into the nose board, and it's quite accessible. Put your miniquad on a nice level flat surface, that's quite important, and load up the software on your computer. The other end of this has a USB, of course. I'm going to plug it into the computer, but not just yet, because what I'm going to do now is show you the computer screen in close up so you can see what's happening. Now the version of the Baseflight configurator I'm using on this is quite old, and I haven't bothered updating it, but the version you're likely to download to do this May look a bit different, but fundamentally it will be the same. If there's any real issues, I'll make a note of it in the description, and maybe I'll point you to another video which I might have to do later to correct any mistakes I make in this one, if people point out and say that looks nothing like the new version. Okay, so here we go. It's just worth mentioning at this point that you're going to have to download not only the software, the Baseflight configurator, which is a application or an app that runs in the Chrome browser, but you're also going to have to download some drivers that will recognize the NAS32 board. Now, I'll put some links in the description here of where you can go to download those drivers. It's a bit fiddly, but it's really not that hard to install them. So install your drivers, and then your Baseflight configurator will be able to talk to the NAS board. Now, I'll go up here to my Chrome app launcher, and I've got to click that twice, don't I? Yeah, here we go. And this is a really slow computer. Oh, I wish I had a faster computer, but it's all I can. I'll replace it eventually. When I get some more money, I'll replace it with something that's got more than 3 bytes of memory and doesn't have a hard drive that runs at 16 1/3 RPMs. Right, here we go, Baseflight down here. If you can't see this, switch to HD, and you'll hopefully be able to make out what's happening on the screen here. So load up Baseflight, and as I say, it's a very slow computer. Here we go, Baseflight, and it's sitting here. I will plug in the USB lead to the computer now. Remember, it's already plugged into the NAS board. Plug it into the computer. Lights come on the NAS board to indicate that something's happening, and bingo, there we go. Now, as I say, your screen will look a bit different to this. This is a really old version. I don't even know how old it is. I think it dates back to the early 14th century, but maybe I'm wrong. So there we go. Now, remember, I pointed out the way those motors are numbered. There they are on here. If you ever forget, it's on the NAS configurator. What we need to do first thing we have to do is up here, calibrate the accelerometer. Now, these NAS boards have accelerometers in them that tell them which way is up, and we need to calibrate it. And this is why we also have to have our multirotor sitting on a flat surface, because if you calibrate it with the multirotor on an angle, it will never self-level. It will self-angle instead. So let's just go up here, we click on there, and you'll notice things happening up the top here in this window. It says calibration started, finished. That was pretty simple, wasn't it? Very straightforward. So now we have calibrated our accelerometer, and if we tilt our multirotor, notice that the little box there, and that's actually a box, see, it's a little box there. As I move my multirotor, the box should track the movements. So that's all looking really good at the moment, and if that doesn't happen, well, there's something wrong. So the next step is we need to tell the NAS board a few things about our setup, and to do that, on this version of Baseflight anyway, we've got to go over to something called the CLI, the Command Line Interface. Oh, it's a big long technical phrase, but what it basically means, it's like DOS. Anyone remember DOS? Hands up? No hands? Okay, I'm older than I thought. Anyway, this is a screen where you have to type stuff, and it puts text up in response. Down the bottom here, there's a little field where you can type things, and I'm going to type in the word dump, which tells me, bang the camera, which tells the computer to tell me everything it's able to do and all the current settings. Whee, see, let's scroll past. Now I can go over here with my little scrolly finger, and I can bring all that back, because there are some things we need to change. See, we can go right back up to the start here. So this is the current configuration. I'll tell you what some of these things mean. Just briefly, this information's online, plenty of sources, other videos online you can use to basically check up on what I've said here, but mixer quad X, because the NAS board will do tricopters and octocopters and hexacopters anyway, you need to tell it what type of machine you're flying. Now, quad X is the default, fortunately, because that's what we're flying. We don't have to change that. And then we have another set of things here called features. Feature PPM. Now, as I said, I'm using CPPM, sometimes just called PPM, which means all the signals come out of the receiver on a single line or single wire. There's plus, minus, and then there's a signal wire. By default, because this has a minus beside it, it means PPM is not enabled. So if we try to use the NAS board now, it wouldn't work. We have to tell the NAS board that we're going to use CPPM, or we're going to use PPM. Now, if you've got a receiver that doesn't support PPM, it has all those individual wires for each channel, and you've plugged them into the receiver, then you can ignore what I'm about to say. But if you have a receiver that uses CPPM, then you have to type this in. You have to type in, if I can reach around, I'll bang the camera every time. Poor positioning of the camera. I'm going to type feature, oops, I have to go down to the input line down here, and I type in feature PPM. And now it says it's enabled PPM. So now the NAS board will be listening for a CPPM signal or a PPM signal on channel 1 of the input. Woohoo! We're part way there. Next thing, I'm going to go back and look at some of these other features, because we've got a few more to change if you want to. A lot of these now are pretty optional. But one of them is motor stop. Now, the default action for the Naze board is when you arm it, the motors will start spinning. Now, they won't spin fast, they'll just spin slowly. But yeah, I don't like that. I just like to have my quad sitting there, even if it's armed. So if you don't want the motors to spin as soon as you arm it, then you can enter this command, which is feature motor, and then an underscore, sorry, and that shift key's a bit bung, isn't it? Computer's crapping out. Stop. Feature motor stop. And it says enable the motor stop feature. So now when I arm it, the motors won't spin up and possibly frighten me, because I'm very easily frightened. I'm old, you know what it's like. So that's all we have to do at this point. I think we'll just go back and check. Yeah, that's the only features we have to enable. Now there's some other stuff down here, a whole lot of crap down here. One of the really important ones here is this here, map, AETR1234. What does that mean? Well, if you're using Futaba or anything that's Futaba compatible and has the channels in the order aileron, elevator, throttle, rudder, which is pretty much the convention for everything apart from Spectrum and JR, then you can leave that as it is. But if you're using a JR or a Spectrum set, then your channels come out in a different order. Why? I don't know. Just because JR wanted to be different, I suppose. The JR channels come out in the order of TAER, throttle, aileron, elevator, rudder. So what you have to do is type in map TAER1234. And that will then tell the Naze board to expect the data in a different sequence. Now I'm not going to change the map here, so that will just stay as it is. But as I say, if you've got a Spectrum, then this is what you would type. And then you would hit enter, and it would remember that information. And another thing to remember is might need to change is this set mid RC. Now that's the center point of your channels. With JR, with high tech, with free sky, with a lot of radio gear, the center point of your channels is 1500 or 1500 microseconds. Yeah, 1500 microseconds, 1.5 milliseconds. That's this number here, 1500. That's the number of microseconds. Now, Futaba, just as JR are different with their channel ordering, Futaba are different with their center point. Oh, why? I don't know. A point of distinction, perhaps. So if you've got a JR or I think a Spectrum set, and I'll just confirm that if I'm wrong, I'll put something down here on the video, but JR and Spectrum, you need to change this to type in mid RC, so set mid RC equals 1520. And that will then align the center point of your channels on your radio gear to what the Naze thinks is the center point. So much farting around, but this is so much simpler than some of the flight controllers. Trust me, we're nearly there, we're nearly done. Apart from that, there's really nothing else to do. If we, what we can do now is we can type in save, S-A-V-E, ka-ching, and it says saving and rebooting. Now, you don't actually have to type that step in because when you go back to the main screen, it automatically saves, but I always do it just for peace of mind. Now I'll come back to my initial setup screen, and when I click on there, you'll see it's saving and rebooting again. Hopefully, come on, there we go. Bingo, we're back to our main screen. So now we've got a couple of other things to do. There's a few more screens here. One of these is PID tuning. The brilliant thing about the Naze 32 board is you can fly it without touching anything. In one of these little ZMR 250 frames, this board will work just the bee's knees without even changing any of these numbers. Now, I will show you some alternate numbers to put in later on, which will make it handle even better, but at this stage, you won't have to really worry about those. Woohoo! What you can change, however, is the roll and pitch rate and the yaw rate. Because when you start off, it's going to be very, very sedate, very easy, very soft on the controls. So we're going to leave these for the time being, but I'm going to come back later and show you how to jazz it up a bit, make it a bit more feisty on the controls. And I'll also tell you about this TPA value here, which, as it's configured, when you nail a throttle in this thing, it's going to shake like hell. It's going to go, well, you've probably seen videos where it oscillates and vibrates. And that's because the gains are too high for high power settings. We're going to come back later on, we're going to retune the Naze board, but we really just want to get you in the air as soon as we can, so we're going to leave it like that for the time being. Now, we're going to go over to receiver now, and we're going to get the transmitter, and we need to turn the transmitter on, and we will need a battery for the miniquad. Okay, now so I turn my transmitter on, I've plugged the battery in.
Welcome to Toronto's.
Hello, young lady. Thank you. And you'll notice now that this will give me an alarm because I've got telemetry set up already, and I don't have a telemetry thing set in. So this woman's going to nag at me right throughout this little bit of the video. I'm terribly sorry. I apologise on behalf of all you people. Now, you notice that when I move the sticks, I'll try and get this in shot. the bars move. Different sticks move different bars. It's pretty simple. And even the throttle here, you can put the throttle up there. So what we have to do is two things. We have to set the midpoint and we have to set the end points. And be quiet, woman. So I'll turn her off for a moment. The midpoints here, which is what you see on these channels, should be close to the value we set before or we observed before. In the case of your JR gear, your high-tech gear, your free sky gear, most of your gear, that's going to be 1500 in this column over here. These numbers should be close to 1500. 1498, yeah, it's okay. 1497, that's okay. They're near enough. Within 5 either way, really, is probably pretty close. If you can get them perfect, that's great. So you want to set the midpoints up. That's what you do. And then the next thing is to set your endpoints, because the ends, just turn her back on again, the ends have to be,
welcome to Toronto's.
Wait for it, and here we go. The ends have to be pretty close to
A2 critical.
2000. So you can see in the case of the top one here, which is my roll, it goes to 1997, which is pretty close to 2000. The bottom end has to be close to 1000. It goes down to 1008. So adjust your endpoints, turn her off. Adjust the center point with your sub-trims to get 1500 or 1520, whichever is applicable, and adjust the endpoints with your EPA or your travel adjust to get 2000 at the top, 1000 at the bottom. It's a bit of farting around. Do it for each of the channels, including the throttle. Make sure that those are all set up. Then your naze board knows exactly what to do when you start twiddling the sticks. One of the big problems I've seen people have is they can't arm their naze board. And quite often it's because they don't have enough throw on the yaw channel, on the rudder channel. And because in order to arm your naze board normally, the default setting is you have the throttle at minimum and you hold the yaw right over to the right. But if it can't go right over to 2000, the board will not arm. People get confused. They go, what's going on? I don't know. Anyway, that's basically the setting of those, the range of those channels. Over here, we've got a few other things like the midpoint of the throttle, the expo on throttle. I don't use any expo. RC rate, leave these as standard. They're fine. They're fine. They'll be perfect for your learning. You can change them later when you want to tune it up. So we've done that. Now on your radio gear, you need to then assign one of these channels to a 3-position switch. Channel, in this case, auxiliary 1 or channel 5, whatever it is on your radio. Just turn her back on again so she whinges.
Welcome to Toronto.
Thank you. And I've got one switch set up here to do that. Where are we? Notice the switch here. Whoops, there we go. Try and get it in shot. This switch here, I've set up a 3-position switch. So that channel goes, at one end it is near enough to 2000. In the middle it's near enough to 1500. At the bottom it's near enough to 1000. So that's all you have to do, set that up, because what we need to do now is set up the auxiliary configuration, as it's called. And this is how we, this is how we can assign the different modes. And we've got the angle mode. Turn her off for a moment. The angle mode, which enables you to fly really easily. It's self-leveling, and when you push the stick over, it will only bank the quad up to a certain angle, and then it will stop. It's about 45 degrees. You can change that, but it's enough to learn to fly with. You can't actually accidentally flip it. The angle of bank or pitch will only go to a certain level and then stop no matter how hard you hold the stick over. That's the angle mode. The next mode is horizon. Horizon mode is just like the angle mode, except if you hold the stick right over, it will actually do a flip. Woohoo! It makes flips really easy, and rolls makes them really easy. And then finally you've got rate mode. And if we look on the screen here, we can see what we've got here. We've got the angle mode, and we've got horizon mode, but there's no mention of rate mode. How do you get into rate mode? Well, rate mode is whatever you aren't using here becomes rate mode. So if it's not angle and it's not horizon, then it's rate mode. So what we do is we turn on our transmitter again. So the little lady stops in nagging. Thank you. And we set the switch to where we want our self-leveling angle mode. So remember, when you notice when I flick the switch, see that little column moves across? So I want this position here, which is the up position, which is the startup position of the radio, to be the safe, super safe angle mode. So I'll go over here to angle and I'll click that box. Here we go. Now the mid position on the switch, I would like it to be the horizon mode. There. Okay? And so now when I switch to that mode, because neither angle nor horizon are inactive, it must be the rate mode. So simple as that. Just follow what I've done there. You can't go wrong. We need to save this. Very, very important that we go down here and save this. Otherwise, nothing will be remembered. So now you'll see we have, these go green and red on the side to show which is active. So the moment angle's active, horizon's active, neither angle nor horizon, so it's rate mode. Simple as that. We're set up. We're done. Dusted. What we can do though is now, I shall turn this lady off again. She's such a nag. We can go down here to another tab, and this is motor testing. Here we go. Now, one of the biggest problems people have, and they say, oh, my quad just keeps flipping. I try and take off and it flips. What do I do? What have I done wrong? Well, what people often do wrong is they connect the motors, the ESCs up incorrectly. So the motors are not connected to the right outputs. And therefore the quad can't stabilize because it's busy, trying to put the wrong commands in. What we need to do is just test to make sure we've got these things wired up properly. So we go down here to this little box. We check on this because that enables us then to activate the motors. We can go across here to any of the channels and we can raise the bar, and that motor, this is motor 1, that motor starts. We raise this one, motor 2, that starts. Motor 3, that starts. Motor 4, that starts. So by doing that I can confirm that each motor is connected to the right output on the NAS board, and if it's not I can change the ESC plugs around to make sure it is. Super simple! Yay! Now we can also do something here. We click on we use the master control to bring all of them up at once, and we can make sure they're all starting at the same time. If they're not starting at the same time, then we need to calibrate the ESCs. Now if you've bought these Afros, they will all start at the same time. They come out of the factory pre-calibrated and they work really well with the NAS, which is one of the reasons I chose them for this project. You shouldn't have to calibrate it. I will show you in another video or in a follow-up to this how to calibrate them, because this is getting too long already and we've covered everything we need to actually put this baby together and start flying it. So maybe we'll just finish this video with a little bit of finish the construction, and we'll take this thing outside and give it a throw and see if it flies. Woo! So here's a mini quad. We've got our NAS board on there. We've configured it quickly with our computer to set up the software. What I'm going to do now, just take this damn thing for a fly. I've had enough sitting around waiting for things to happen. And we'll come back after we've test flown it and we'll put the FPV gear on it. But let's start by putting the top plate on. That's all really simple. Ooh, hang on. And remember, the top plate has to go the right way around. Don't put it backwards or your Mobius will be at the wrong end. So holes for the Mobius at the front, not the back. And another bag of screws. These are slightly shorter than the ones we used on the bottom, but that's not an issue, not a problem. These screws will hold that top plate in place. And remember, we don't have our camera or anything else in place yet. This is just, we're going to do a test fly because we're too impatient. And of course, if you have got this and your FPV gear hasn't arrived, there's no reason why you can't just fly it like a regular sort of non-FPV quad. They will fly very nicely, but small, but easy to lose sight of. But hey, this will give the opportunity to just get a feel for how it flies. But as we know, it's easier to fly FPV than it is line of sight if you've never flown a multi-rotor before, because orientation can be an issue. This is a great opportunity to get in there and have a good go. What I will do, however, before we go flying, is I'll put the LEDs on the front, because the LEDs provide valuable orientation cues if you're flying line of sight, and you don't want to be getting disoriented. So let's go. Here we go, screws. And someone said, whoa, how do you use those long Allen keys? Why don't you have a little handled wrench? Well, I got one, look, see, that actually came with my cine tank. They gave me that as part of the cine tank. I thought that was really rather nice. Made putting the cine tank together much, much easier. So it's become a staple part of my toolkit. And look, you get an extra screw. Whoa, those Chinese, they think of everything. They're so nice, very nice indeed. Here we go, get that in there. I'm not gonna do these up super tight because I'm gonna take them off again later, so we can put the FPV gear in. This will just be temporary. There we go, just make sure they just nip them up a bit. I'm not going to torque the snot out of them. Here we go, so we've now got our top plate on. I'm not going to bother putting the Mobius platform on or anything. I'm just going to push the wires through here. I'm not going to bother putting the cable tie antennas on, because once we've done that, when we take the top plate off, we'll have wires binding up. So I'm just going to push these through here. Come on, come on. Oh, I need to get smaller hands. These hands of mine are way too big for this sort of thing. And we just have to make sure they don't get caught in the props. It's just important I might just put a bit of tape. This is fiberglass, so I could actually take these down here if I wanted to, because fiberglass doesn't affect radio frequency signals in the same way that carbon fiber does. So there we go. That's pretty simple. Now, what I'm going to do now is I'm going to show you. Remember, I talked about this box that the NAS 32 came in, and I said don't throw it away because it's really, really handy. I'm going to show you how handy it is. You can cut this up, right? Cut up this box. Take your little knife like mine and just cut through where it's joined, because you can see it's actually made from several pieces. Just cut it through like so. Cut the top bit off the bottom bit, and it'll give you a nice little rectangle. Ooh, here we go. Because one of the things I used to do with my quads is I used to Velcro the batteries on, and to be honest, it becomes a bit of a pain after a while using all that Velcro on batteries, and it doesn't really stop them coming off. They fall off anyway. So what I found out was, if you get these things here, now you can buy a rubber strip that has self-adhesive backing, and you can put it on there to support the batteries. But what I do is I just get this stuff and I just cut it like so. Now I've got a piece of rubber strip. It's kind of good. It sticks to your lipos. The lipos kind of grip on it, which is great. And there, now I've got 2 bits of rubber strip, and I can use these on here like so by simply putting a bit of double-sided sellotape on the back. And look at this, I haven't even lost my double-sided sellotape. How cool is that? Getting almost organized here. So what I do is I lay my double-sided sellotape down, I get my piece of foam rubber, do it in shot, and I stick my piece of foam rubber onto the double-sided sellotape like so, press it down, chop the ends off, and homemade rubberized strip that goes on there and stops your battery moving about. Oh, tell you what, talk about Scrooge, I'm your man. And now I've lost the other bit. What to do with it? Oh, it's on there. Here we go. Right, so I'll put these on and then we'll look a bit further at what we do. There we go, look at that, pretty snazzy, eh? Pretty cool, pretty good. So now I've got these, so that when I put my battery on here, and this battery does have Velcro because I've used it before. When I put my battery on here, this rubber actually really grips well, and as you can see, it's not sliding at all. So it saves me wasting heaps and heaps of Velcro on my batteries. My new batteries, I don't bother. And all I need to do is put a battery strap around there, and because you get battery straps from everywhere, every man and his dog has them. And then you can, as you clamp down your battery, or pull your battery strap tight, it compresses that rubber and it grips even more. And that's very important because once you get FPV flying, if your batteries come off in a crash, you may find it more difficult to locate your miniquad, because as long as you've got power, you can give the motors a rev and you can hear it. So if you crash into long grass or something, you can track it down by ear, or using the telemetry method that I spoke about some time ago, did a video on with the Tyrannus, or with the FreeSky system. How you can use the FreeSky telemetry to track down your errant models. Right, I've got a battery strap which I can use to hold my battery down. But before we do anything else, I remember I said we were going to put these LEDs on, and this is the Hobby King LED strips. And as I said, you can just chop these. They have little intervals marked on them. Get rid of my double-sided tape off here. Little cut points marked on them here, where you can just take a pair of scissors and you can just slice those little babies into strips. So I'll just slice that one off there. Woo, there you go. Not really sacrilege at all. So that, I don't even know what color these ones are actually. So now you can stick these across here on the front of your frame. That's usually where I put them, just behind or just in front of those bolts. And these wires that we ran before, which unfortunately that bit of the video didn't record, damn it. But basically I've just got some red and black wire. Let's go back to that power board there. Red goes to one side, black goes to the other. That provides us with the 12 volts to power our little LEDs. So what I'm going to do is I'm going to mark out, or cut these to length so I know roughly the right length. Here we go. And then I'm going to strip them back, and I'm going to solder them to the LED strip, making sure I get the polarity right, of course, because that's really important. I have put some solder on the end of these points here. You have to use quite a bit of solder on there, and I've got these wires which I've tinned. I should turn my viewfinder around so I can find it easy to orient here looking at the viewfinder. So now I'm just going to solder these onto here, making sure I use the right polarity to avoid, well, in fact, if you put the wrong polarity, no smoke comes out. They just don't work. So bear with me while we do this. Can I do it in shot? It's really, I should get a better camera system for this, for doing this close-up work, because it really is quite difficult to do all this stuff in shot. And there we go. And this one, try to keep them fairly well spaced so they're not going to be at risk of banging together. There we go. Voila! Simple as that. Then you just peel the adhesive backing off. Takes his granny glasses off so I can see what he's doing. Just get the adhesive backing. Oh man, I might have to get my knife out for that. It's pretty stuck on, that backing. But that's good because it means your LEDs won't come off in flight. Here we go. Peel the backing off, and then, as I say, just position them. I tend to position mine just in front of all these bolts. Try and get them straight. I might be out of shot for this because I need to line it up. It doesn't matter if it's a little bit crooked. No one's going to know. Really, honestly, nobody's going to know. I noticed I didn't do that bolt up very tight. I need to check my bolts. Oh no. So there you go. Let me just pull out of that so you can see. And very slow zoom out on this when you're on the remote control. So there you go. There's our LEDs on the front of our quad, and they will light up. What you can do with this wire here, that's poking out, just push it back in. It'll go quite nicely in between those plates. Won't cause any problems. Look at that. We've got LEDs on a ZMR, and it only cost us next to nothing because these are about $4 or something a strip. You get, quite a lot of LEDs out of them. You could also put a strip along the back, preferably a different color to help orientation, but I can't be bothered. This is going to be enough for us right now. So all we've got to do is slide our battery in here, like so. Get a good battery strap. One thing I find, good battery straps are worth their weight in gold. This is an ex-Hover one. It works quite well. I really like the Luminaire ones because they're kind of like rubberized and they grip the batteries really, really well. But hey, this one, as long as you pull it down tight, see, that's not going anywhere because of the bits of Naze board box that do the job of expensive rubber strip. Bit of Naze board box, bit of double-sided sellotape. Woohoo, saving money all the way. This is a budget build, remember. Now, I mentioned about these wires before, how they get in the way, and of course so many times I've seen people and the wire falls down there and the prop goes munch, 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 and that's the end of your battery lead. So what I do, as I said, is I tend to rubber band or cable tie one there. So once you've plugged this in, there's nowhere for, all out of shot so you can't see. Once you've plugged this in, it's all sort of out of the way. It's not going to go anywhere. It's not going to get caught up in those props. So that's what I'm going to do now. I'll put a cable tie around here. I should have put a rubber band around because rubber bands give you a bit more movement. But I will put a cable tie around there, and no, we'll use a rubber band. Damn it! I'll go and find a rubber band this to the post. So with the rubber band, you've got a bit of movement. You can slide it around to get it all sort of in the right place for putting your battery in. Let's do it. Right. So I didn't have a rubber band the right size, so I'm just going to cable tie this to the pillar. So it's not going to go anywhere. And you can just loosely cable tie. It doesn't have to be tight because it's not, in fact, you want to leave it a bit loose so you can actually move that cable around if you need to. And that's what I'll do. Just thinking I should have it. Yeah, this will work. This will work. And here we go. So that can go down a bit. Put that in there. This will now give me just a little bit of, you can see that's popping up the back there. So my battery lead now, when I plug my battery lead in, it's going to be quite a tight fit, which means that this battery lead here it's kind of poking up a lot, but it's not going to be too much of an issue. I can actually move it around once I've got it plugged in, but it's not going to fall into the propeller. It's not going to fall, which is really bad. When that happens, it is really bad. So now throw some props on this. Okay, now you'll remember in the first video I said, don't buy 4 motors, buy 5. Don't buy 4 ESCs, buy 5. I'm going to show you why that was very sage advice. I've just been going to put the props on the frame. Now it's all put together. You think, what could possibly go wrong at this stage? Well, I thought, yeah, this will screw onto here. That's fine. Look at that. That's all okay. But when I got to put the prop on this side, I thought, hang on, this is a bit wobbly. And oh, that doesn't actually screw on. What's going on? These prop adapters here are 5mm, which is great because you don't need to use spacers with your props. The props just slide on. It's 5mm hole, 5mm drive. That's fine. But this one, I didn't notice when I was putting together, this one has a 4mm adapter. What? If I hold them up, you can see the difference, hopefully. This is a small, so of the 4 motors, one came with a 4mm adapter. Now it's not the end of the world because we could still use the props with a spacer, but I don't have to use a spacer on that one prop. I'm really peed off. That is awful. And this is the problem that you get when you buy cheap. Well, there's sometimes the problem still occurs if you buy expensive. And of course, if we contacted Banggood, it's not Banggood's fault because they didn't make the motors. It's DYS, very poor quality control at DYS. They put a 4mm thing into the box instead of a 5 one. If you contacted Banggood, they'd say, send it back and we'll send you a replacement. But that's a $9 motor. Are you really going to send it all the way to China just to get a new adapter? So hopefully, the spare motor that I bought will have the right sized adapter in its box. And if it doesn't, I'll be really pissed off. So let's have a look in here. Maybe we've dodged a bullet by buying 5 instead of 4. Let's have a look. Drum roll, please. Propeller. Yes, it's a 5mm one. So there's the benefits of buying a spare. As I said right at the start, buy a spare. Be prepared, because if you'd bought this and you were all ready to go and you realised, oh man, my perfect new mini quad has got one motor where the shaft, the prop mount, the prop adapter is smaller than the rest, you'd be a bit peed off, wouldn't you? You'd be quite peed off. Well, I would be. Some people wouldn't care, but I mean, oh, you're building a brand new machine. You want everything to be right. And they send you a bum adapter. So I'm going to change this one out because I want all mine the same. I don't want to have to fart around finding spaces for my props when I go to change them. And this, children, is why we don't use red Loctite, because sometimes the bolts you thought would stay in forever actually have to come out. And if you've used red Loctite, you'd be changing the whole motor, which would mean unsoldering stuff, farting around. But because we've used blue Loctite, we can simply take out the bolt, take out the thing and replace the hub instead of replacing the whole damn motor. So we've still got a spare motor, but we don't have a spare hub because this is the wrong size. A curse on your house, DYS. Shame on you. Oh man. Fortunately, I noticed this is, people say, well, why do you buy expensive motors? What's the point of spending 40 bucks on a T motor when you can get one of these for a quarter of the price? Well, I'll tell you, one of the reasons is the T motor comes with multiple adapters. It gives you a 4mm and a 5mm, depending on what you want to use. Brilliant. It seems that with the DYS, sometimes just a lucky dip. Lucky dip what you get. Who knows what the next box will have in it? So, yeah. I mean, this is a budget build and I have to expect that some compromises will be made, but I don't expect to get the wrong parts. Don't expect to get the wrong parts, people. So now I'll put this one on, go through the process of Loctiting it again, and then we'll put the props on. Okay, so now we're out of the workshop now. We've got it together. No FPV gear, as I said, but what I'm going to do is just make sure it flies. I mean, how sad would it be if we got to this stage and the damn thing didn't work? So I'm going to plug it in and we're going to give it a go. Okay, so here we are. It's time to give this a throw in for the people at Model Flying New Zealand. They tell me you should always test glide your models, hand launch them the first time. So let's see what happens. Well, it seems to fly.
Really difficult with dear eye thing. I have. Yeah. Yeah, I have done that. But it's very hard to track.
It's alright.
Yeah. Yeah, it's just incredibly difficult to track. No, I'm zoomed out a bit. There it goes.
So there we go, it flies. What more could you wish for? It's that's the nose board, stock standard settings, no problems. I think now we're ready to go back, do another part in this build video, put the FPV gear in, and also connect up the telemetry so this lady in my Tyrannus stops nagging at us. So tune in for the next episode coming up really soon on the RC Model Reviews channel. Thanks for watching. I better go back to the bench.